In this podcast, we will learn about atom. So first question is, what is atom? Atom is fundamental unit of matter. Everything found around us like iron rod, glass, cup, pen, pencil, door, chair is made up from very small particles. These small particles called as atoms. Greek philosopher Democritus described atom as a very small individual particles. Means these particles cannot be divided further. There is a book of John Dalton written in 1703, New System of Chemical Philosophy. Dalton atomic theory. According to this theory, atom cannot be divided, but after some years it is proved that atom can be divided further by many scientists like J.J. Thomson, Rutherford, Bohr, Chadwick, etc. Constituting particles of atoms. Atom made up from three main particles, that is electron, proton, neutron. Now we learn about this electron. Who discover electron and how discovery of electron happen? So our title is Discovery of Electron. Sir J.J. Thomson and W. Crookes did many experiments with discharge tube for the discovery of electron, and after some time they discovered it. Discharge tube have tube like shape made from glass with two electrodes, cathode and anode, in vacuum created by vacuum pump connected to discharge tube. High electric potential is applied between two electrodes. Means these two electrodes are inside what? Inside discharge tube, and vacuum is applied in discharge tube, and high electric potential is applied between these two electrodes. Then what happen? Air is bad conductor of electricity, so vacuum pump is connected to reduce the pressure to 0.02 mm inside discharge tube. Currents flowing between electrodes and light is emitted. On further reducing pressure in discharge tube, greenish yellow color fluorescence occur as these rays emerging from cathode. Sir J.J. Thomson named these as cathode rays. Deflection of cathode rays toward positively charged plate in electric field proves that these rays carry negatively charged particles. These negatively charged particles are named as electrons. Property of cathode rays. Cathode rays always travel in straight line. Velocity of cathode rays and velocity of light are approximately equal. On applying electric field in the path of cathode rays turn towards positively charged plate. That proves cathode rays are made up from negatively charged particles. Cathode rays rotate light wheel placed in their path. That proves cathode rays are made from particles having mass. Cathode rays pass through thin metal foil and it gets slightly heated up by the action. These rays produce fluorescence at walls of glass tube. Cathode rays ionize gases and also affect photographic plate. When these rays strike any metal with high melting point like tungsten, they produce X-rays. What is X-rays? X-rays are electromagnetic radiation. X-rays was discovered by W.K. Roentgen in 1895. X-rays are also known as Roentgen's rays. Why X-rays are used in medical sciences? X-rays are used in medical sciences because X-rays have high penetrating power. Now we learn about E by m, that is determination of charge to mass ratio of electron. Sir J.J. Thomson conduct many experiments that charge to mass ratio of an electron remains same, that is irrespective of nature of gas and nature of cathode electrode material. Value of E by m is equal to 1 minus 1.76 into 10 to power 8 coulombs per gram. I repeat, value of E by m, that is mass charge to mass ratio of electron E by m, is equal to minus 1.76 into 10 to power 8 coulombs per gram. Okay, now we learn about Millikan's oil drop experiment. Millikan's oil drop experiment or determination of charge of electron is conducted by an American scientist R. A. Millikan, who performed an experiment on the charge on oil drop. R. A. Millikan performed several experiments to calculate charge on oil drops, and he gets every time its value equal to minus 1.6 into 10 to power minus 19 coulomb. When these results associated with results of cathode rays, then conclude that charge present on particle of cathode rays is minus 1.6 into 10 to power minus 19 coulomb. Calculation of mass of electron. As we know, E by m is equal to minus 1.76 into 10 to power 8 coulombs per gram. So E is equal to minus 1.6 into 10 to power minus 19 coulomb. Then E by m by E is equal to minus 1.76 into 10 to power 8 divided by minus 1.6 into 10 to power minus 19. So m is equal to 9.102 into 10 to power minus 28 gram. Also, in units of kilogram, it is 9.102 into 10 to power minus 31 kilogram. Mass of electron in comparison with atom. Mass of electron in comparison with atom is described below. Mass of 1 mole of hydrogen is equal to 1.008 grams. Number of hydrogen atoms in 1 mole is equal to 6.023 into 10 to the power 23. Mass of 1 atom of hydrogen is equal to 1.008 by 6.023 into 10 to the power 23. That is equal to 1.667 into 10 to the power minus 27 kg. Mass of electron is 9.109 into 10 to the power minus 31. Then mass of 1 atom of hydrogen divided by mass of electron is equal to 1.67 into 10 to the power minus 27 divided by 9.109 into 10 to the power minus 31 is equal to 1837. So mass of an electron is 1 divided by 1837th the mass of a hydrogen atom. Now we learn about discovery of proton. As we know, electron is negatively charged particle, but atom is electrically neutral. So there should be some particle which have positive charge to neutralize negative charge of electron. In 1886, a German scientist E. Goldstein established the presence of positively charged particles. These positively charged rays travel from anode to cathode, so called as anode rays or positive rays. Why anode rays are called as canal rays? Anode rays passes through canal or perforation in cathode, so called as canal rays. Properties of anode rays. Anode rays always travel in straight line. Anode rays rotate light wheel placed light wheel placed in their path that proves anode rays are made from particles having mass which produce mechanical action. On applying electric field in the path of anode rays turn towards negatively charged plate that proves that anode rays are made from positively charged particles. Determination of charge to mass ratio of proton E by m. On the basis of many experiments performed for anode rays, scientists Wien conclude that charge to mass ratio of proton change with change in nature of gases present in discharge tube. This value E by m is maximum for hydrogen gas is equal to 9.58 into 10 to the power 4 coulomb per gram. Positively charged particle of hydrogen is fundamental particle of matter that is called proton. Charge on proton. Charge on proton is equal to charge on electron but is of opposite nature. So charge on proton is equal to 1.602 into 10 to the power minus 19 coulomb. Mass of proton for hydrogen gas E by m is equal to 9.58 into 10 to the power 4 coulomb per gram. Charge of electron is equal to 1 charge of proton is equal to 1.602 into 10 to the power minus 19 coulomb. So m is equal to E by em is equal to 1.602 into 10 to the power minus 19 divided by 9.58 into 10 to the power 4. Also m is equal to 1.67 into 10 to the power minus 24 gram. So m is equal to 1.67 into 10 to the power minus 27 kg. So mass of proton is 8037th times more than mass of electron and is equal to mass of an hydrogen atom. Discovery of neutron. Mass of atom is more than the mass of total proton and electron present in atom, which suggests the presence of another particle in atom, which lead the discovery of neutron. Chadwick in 1932 discovered neutral particles of mass equal to mass of proton by bombarding beryllium metal with stream of fast moving particles through cyclotron. These particles are neutral in nature, so named as neutron. Mass of neutron is equal to 1.6748 into 10 to the power minus 27 kg. There is 3 fundamental particles in atom. These 3 fundamental particles are electron, proton and neutron. Many atomic models are proposed from time to time to show the actual structure of atom. Some of them are described as Thomson's atomic model, Rutherford atomic model, Bohr atomic model. According to Thomson atomic model, Thomson atomic model is first atomic model proposed in 1898 related to atomic structure. This model is similar to watermelon, in which positively charged proton is like pulp, in which negatively charged electron like seeds is in watermelon, also known as pudding model. This model is called Thomson atomic model. Drawback of Thomson atomic model. Thomson atomic model is unable to explain scattering experiment of Rutherford. Rutherford model of atom. This experiment is also known as alpha particle scattering experiment. Rutherford bombarded alpha particle on gold foil of thickness 0.0004 centimeter and found that so many particles passes through the gold foil without any deflection. Some alpha particles are deflected at different angles. Very few, about 1 in 20,000, are bounced back at 360 degree from gold foil. Rutherford concluded nuclear model of atom, as most of the part of the atom is hollow and neutral, so alpha particle passes straight without any deflection. All charged positive charge is present in center of atom, so alpha particles are deflected at different angles by repulsion from positive charge center, known as nucleus. Only very few particles bounce back, so size of nucleus is very small as compared to size of atom. Electrons moves around nucleus like planet moves around sun in orbit. Mass of electron is negligible, so all masses of atom is present in nucleus. Atom is electrically neutral, so number of electron is equal to number of proton present in atom. Defects of Rutherford atomic model. Stability of atom is not explained on the basis of this model. This model could not explain discrete spectrum. Bohr atomic model. Niels Bohr in 1993 in 1913 sorry Niels Bohr in 1913 gives a simple model of four atomic structure based on the quantum theory. Main assumption of Bohr atomic model: all atoms consist of dense, very small, positively charged nucleus that have all protons and neutrons in it. Electrons revolve around nucleus in definite energy paths known as orbits, shell, or energy levels. Orbits denoted by n, value of n is whole number 1, 2, 3, 4, etc., which are represented as k, l, m, n, etc., respectively. As we increase the value of n, the orbit moves farther from nucleus, means distance between nucleus and orbit of higher n is more than smaller n, and their energy also increases. So n is equal to 1, or k cell have lowest energy. If an electron revolve in the same energy level, then there is no change in the energy in its energy level. As electron absorb energy from outside, it get excited and move to higher energy level and come back after emitting energy to lower energy level. Atomic number. Number of proton present in nucleus of atom of an element is known as atomic number. It is denoted by Z. Example: carbon have 6 proton, so its atomic number is 6. For neutral atom, atomic number Z is equal to number of protons is equal to number of electrons. Number of protons in cation more than number of electrons in cations, because cations formed by losing electron. Number of protons in anions are lesser than number of electrons in anions, because anions are formed by gaining electrons. Number of proton in neutral atom is equal to number of electron in neutral atom. Mass number. Mass number is also known as atomic mass. Atomic number or mass number is equal to number of proton and neutron in atom. So atomic mass is equal to number of proton plus number of neutrons. So A is equal to P plus N. Example: helium have 2 protons and 2 neutrons, so its atomic mass is 2 plus 2 is equal to 4. Isotopes. Atoms of same element which have same atomic number but different atomic masses different atomic mass number is called isotopes. So isotopes are atoms of elements which have same atomic number but different mass number. Example: protium, deuterium, tritium are isotopes of hydrogen. Types of isotopes: non-radioactive isotopes. Example: carbon 12, carbon 13. Radioactive isotopes. Example: uranium 235, uranium 233, uranium 238, uranium 239. Isobars: atoms of different element which have similar atomic mass and different atomic number are called isobars. Example: calcium 40, argon 40, krypton 40. Isobars do not similar in physical and chemical properties. Distribution of electrons in various orbits. Bohr-Bury scheme. In 1921, Bohr and Bury gives some law for distribution of electrons in various orbits, which are called as Bohr-Bury scheme. Rules of Bohr-Bury scheme are as follows. Maximum number of electron in any cell should be 2n h to the power 2, where n is serial number of cell. Maximum number of electron that exists in outermost cell or orbit of any atom is 8, while maximum number is 18 for pneumatic cell. Ultimate cell. According to this law, it is not necessary that another cell is formed after completion of first cell. A new cell is formed as number of electrons reaches 8 in any orbit or cell. Valence electron and valencies. Outermost incomplete cell of any atom is known as valence cell, and electron present in incomplete outermost cell are known as valence electrons, which participate in formation of bond. If atom have 1 to 4 valence electrons, then valency is equal to number of valence electrons. If atoms have 5 to 8 valence electrons, then valency is equal to 8 minus number of valence electrons. But these above rules is not applicable to atoms which show variable valency. Radioactivity. Radioactivity is discovered by French scientist Becquerel in 1896. Substances which emits radiation is known as radioactive substances, and this property of substance to emit radiation is called radioactivity. Example: uranium exhibits radioactivity. Rutherford conducts some experiments with radioactive substances, and his observations are as follows. Rays which turn toward negative electrode is known as alpha rays. Mass of alpha particle is 4 AMU atomic mass unit, and charge is 2 units of positive charge. Rays which turns towards positive electrode is known as beta rays. Mass and charge of beta particle is equal to mass and charge of electron. The rays which do not turn towards any electrode is known as gamma rays. Gamma rays are electromagnetic rays and not made from matter particles. Penetrating power. Gamma rays have highest penetrating power, then beta rays, then alpha rays. So alpha rays have lowest penetrating power. Gamma rays have maximum penetrating power while alpha has lowest. Tracer technique of radioactive isotopes. As per requirement, small amount of radioactive isotopes is added to its element, then many physical and chemical complex reactions are studied. Various field of tracer techniques, in the field of chemical science, in the field of medical science, in the field of agriculture, in the industrial field, and in other scientific field. Carbon dating. In this technique, carbon isotopes is used to determine the age of rocks, minerals, fossil fuels, dead animals, and dead plants. Okay, friends, now we complete our atom chapter, and follow us and subscribe our YouTube channel, visit our website, download PDFs from our Telegram channel of this chapter. Thank you. See you soon in our next podcast.